Hey J-Physics, looking at a graph that's position versus time, we can actually extract a lot of information. Remember, if we find the slope at any point on this line, since slope is the change in y over the change in x, and we look at the units for y is in meters, and the x-axis is in seconds, position versus time gives you meters per second, which is velocity, right? So if we look at question number 5 here down below, what is the girl's average velocity between 15 and 40 seconds? Well, here's 15 seconds, here's 40 seconds. So between this point and this point, we want to know what the average velocity is. So to find that answer, we just need to find the slope of that line. Now, to find the slope of the line, we can take any 2 points on this actual line. All right? So let's do that. Let's take 2 points that are easy to read. All right, here's 0. Let's see. If I take this point, which is the coordinates 20 and 40 meters, and let's say I take this one right here, which is coordinates 30 and 0, I can take those 2 points, find the slope of the line, and of course, the slope of the line, again, is going to give me meters per second, which is my velocity. So let's plug in. We know that the change in y over change in x is the slope. So here's my xy, xy. So let's do change in y over change in x. So here we go. Let's do 0 minus 40 for my two y values, 0 and 40. For my x values, let's do 30 minus 20. 30 and 20 are my x values. All right, that gives me negative 40 over 30 minus 20 is 10. Negative 40 divided by 10 is a negative 4. And the unit, since it's y over x, is meters per second. Does it make sense that it's a negative number? Sure thing. This is a negative slope, right? And what does a negative velocity mean? It means that you are going backwards, all right? But since it's a straight line and it's angled, it means that it's a constant velocity at that point. You just happen to be going backwards, and that's why we have the negative there. All right? So using position time graph, simple as that, just take the slope of a line, and that will give you the average velocity at that point. I hope this was helpful. Question number 6 of this worksheet says, what is the little girl's total displacement after 55 seconds? We know that total displacement, all we care about, is the initial and final position. So the initial position of the girl is 0 meters, and the final position of the girl is 0 meters again. So our displacement, we remember, is equal to final position minus initial position. And in this case, 0 minus 0 just equals 0 meters. So this young girl does not have any total displacement whatsoever. Question number 7 leads us to describe the motion of the young girl from 25 to 35 seconds. So from 25 to 35 seconds, a lot is going on. Now, for position, when you go up, you're moving forward. When you go down, right, you're moving backwards, right? So in this case, this girl, since the slope is going down, the girl is moving backwards, right, from position 20 to position 0 to position negative 20, right? So if this is like a football field, and it goes from 20 to 0 to negative 20. Don't get all worried about a negative 20, right? That's just 20 meters before the starting line. You're still moving backwards. And since this line is a straight line, we know that means constant velocity as well. So the girl is moving backwards the whole time. And also, again, because the slope is negative and the line is straight, it's a constant velocity as well. And we can relate that back to our lab with uniform motion, where we had data with the line of best fit that showed that it was pretty much a constant velocity. As time went by, the same displacement happened per unit of time. The question is, what is the girl doing between 10 and 15 seconds for question number 8? Well, 10 seconds is right here, and 15 seconds is right here. So the position starts at 60 meters and ends at 60 meters. So even though 10 seconds have gone by, or forgive me, 5 seconds have gone by, has this person moved at all? The question is no. So there's no movement. The person stopped moving. And that makes sense because on a position time graph, slope gives you velocity. But if there's no slope, there's no velocity. Therefore, there's no movement. So this makes sense. Question number 9 asks, what is the girl's total displacement after 20 seconds? Again, total displacement is going to be the change in displacement, which means the final position minus the initial position. So let's look, after 20 seconds, you end up here. So your final position is at 40 meters. Your initial position was at 0 meters to start. 40 minus 0 is simply 40 meters is your total displacement. And notice that's a positive 40 meters, meaning you went forward 40 meters after those first 20 seconds. Our final question is, what is the girl's average velocity between 40 and 55 seconds? So if we look 40 seconds to 55 seconds, that is the line between the two. Now remember, velocity is displacement over time, which happens to be the same as our slope, which is y over x, because displacement or position is on the the y, and x-axis is time. Now don't get confused with these two delta x's, all right? This is displacement where this is the x-axis. This is just slope, all right? So I'm not trying to confuse you there. Anyways, let's work through this. To get slope, we want to take 2 points on the line that are easy to read. No problem. It looks like at 40 seconds, all right, we are at a negative 40 position. And it looks like at 55 seconds, we are at 0. So let's just do the math really quick, right? This is x, this is y, this is x, this is y. Let's subtract 0 minus a negative 40 for my y's over my x's, which would be 55 minus 40. All right? Minus a negative 40 is a positive 40, and 55 minus 40 is 15. Let's divide that out. And after we divide it out in the calculator, I ended up getting, and forgive me, I'll put my number over here, 2.67. And the units, of course, y over x are meters per second. So by finding the slope, we find the average velocity between those times. Again, a straight line leads us to having a slope, and because of looking at the units, meters per second, it tells us it gets velocity. Important here is that it is a positive number, showing the velocity is positive, meaning this object is moving forward, which makes sense because you're going from the negative 40-yard line to the negative 20-yard line to the 0 starting point. So even though you're in the negatives, you're moving forward towards the starting line again. It's like you're behind the start. Anyways, I hope this was helpful in walking through the backside of your worksheet. Best of luck and feel free to ask questions in class.